A typical DC motor would consist of the following simple components: an inductor L and a resistance R that represent the inductance and the resistance of the coil in that motor. We would apply an input voltage Vin to this motor, and the motor would generate some kind of a back EMF epsilon. The motors also would have a shaft which would have a moment of inertia J, and it would rotate at a speed omega and would produce a torque tau. How would we write down the equations of the electrical part? We would apply Kirchhoff's voltage law along this loop. And the voltage law would just say that Vn minus Vl minus Vr minus epsilon equals 0. Let us assume there is a current I that flows through this. So Vn minus L, Vl is L di dt, minus Vr is by Ohm's law given by IR minus epsilon equals 0. This is the first equation that we will use to generate our system of equations. Another thing to note about a DC motor is that the torque is going to be proportional to the current. Now the torque will equals K times the current, where K is something that we call the motor constant. If power is conserved across this motor, then the torque multiplied by the angular velocity would equal the voltage epsilon multiplied by the current I. Again, torque is given by Ki, then Ki times omega equals epsilon I. So epsilon would equal K omega. These two equations give us a way that we can go between the electrical domain and the mechanical domain, and it will help us generate a system of equations.